Today's lesson is on Venn diagrams, and if you remember, we looked at some Venn diagrams when we first started talking about conditional statements. Remember, and we saw that our hypothesis would always be inside and our conclusion would be in the larger circle. So we're going to carry that a little bit farther today. So let's see what our first statement says. We can use a Venn diagram to illustrate how the set of things that satisfies the hypothesis of a conditional statement lies inside the set of things that satisfy the conclusion. So there that is, just like we had seen before. So let's do some more examples. Let's draw a Venn diagram for each statement below. Okay, so we know the hypothesis always goes inside. So what is our hypothesis? A polygon has 8 sides. So I got to abbreviate this because I can't draw my circles large enough to write all those words in there. If a polygon has 8 sides, then it is an octagon. How about that though? Is the converse of that statement true? If a polygon is an octagon, then it has 8 sides? I believe so. This is one that we could write as a biconditional, right? A polygon has 8 sides if and only if it is an octagon. So I think this is one that we could have drawn either way and had it be correct. That's not always going to be the case though, right? Remember, the conditional and converse they don't typically have the same truth value, but if they do, you could write a biconditional and you could draw your Venn diagram either way. Okay, how about this next one? If an angle measures 80 degrees, then the angle is an acute angle. So let's put our hypothesis inside. Angle measures 80 degrees. If it does, then it is an acute angle. So that's saying that all angles that measure 80 degrees are acute angles. So let's think about it. Could we do it the other way? If an angle is an acute angle, then its measure is 80 degrees. Nope, of course not. The converse is not true in that case. So that is the only way that we could draw that Venn diagram. All right, how about this one? I go to the grocery store only on Saturdays. Well, we need to figure out how to write that as a conditional statement, right? And then it'll make our Venn diagram easy. So how about this? Let's see if this is right. If I go to the grocery store then it is Saturday. Now let's think about that for a moment and decide whether that's how we're supposed to say it, or if we're supposed to say, if it is Saturday, then I will go to the grocery store. What is my statement actually saying? I go to the grocery store only on Saturdays. Okay, so it's saying no other day of the week do I ever go to the grocery store. Only on Saturdays do I go to the grocery store. All right, so if this is the truth, here's how this is going to look. I mean, if I have written that statement correctly as a conditional. So if I'm going to the grocery store, I go to grocery store, then it is Saturday. This one is a little bit tricky, so let's look at our Venn diagram. I feel like this is right, but let's make sure. Since going to the grocery store is inside of Saturdays, that says whenever I go to the grocery store, it's definitely going to be on Saturday. If I'm out here, this says it's Saturday, but I'm not going to the grocery store, and that works, right? Because it doesn't say, the statement doesn't say I go to the grocery store every Saturday. It says if I'm going to the store, then it's going to be on Saturday. So some of these can get pretty tricky. So let's be careful. Let's see what else we got here. Oh, here's an example for you. It says write a conditional statement for each Venn diagram. Well, this one we know is going to have a hypothesis and a conclusion. So I'm going to leave that one and I'm going to let you write a conditional statement that fits that Venn diagram. And I am going to check it when I come around to look at your notes. So you better have a statement written down there for that one. This one is a little bit more difficult. So I'll help you with this one. I'll do one and then you see if you can think of one. Okay, what do you know about this part that's included in both circles? that means it applies to both, right? And remember, I know you learned this a while back, but remember that's called the intersection. The intersection is if it's covered by both or included in both, the intersection. So let's see. Let's see if we can figure out, what if I call this P and I call this Q, and the part in the middle has to be P and Q, right? So I'm going to pretend like this one is I do yoga, and this one is I run. Actually, I don't think I should call them P and Q. That's probably not the best thing to do here. So I'm going to get rid of that P and that Q, and I'm just going to label these this way. Because it's not really if I do yoga, then I run. So that doesn't really work out. Okay, here's what I can write though. If I do yoga and run, I'm going to say regularly. Got to do them regularly, right? Then I will be in great shape. Okay, so where should that great shape be in my Venn diagram? It's going to be right here in the middle, right? If I do yoga and I run, then I will be in great shape. So that's what the overlapping looks like. Now, let's do the fun type, and we're going to have lots of practice in class tomorrow, but let's do this one here that's got 3 circles. So what do we got here? We got a group of sports fans were asked which of these 3 sports they like to watch. Football. You should label yours the same way I do, so we can, it's much easier to check if we have all our circles labeled the same way. Football, basketball, and we'll put hockey down here. Okay, now we're going to look at the information that we're given, and guys, sometimes we won't be able to take all these given statements in order. We'll have to jump around in order to fill in our Venn diagram. I'm not sure if that'll be the case for this one or not. So let's see what we got first. 8 said they watched none. They watched none of these. Okay, well that's easy enough. I know that's got to go out there. And as I go, I'm going to check them off so I know that I don't need to come back and account for that number there. Okay, 15. Watch all of these. So I got to look for the spot in the Venn diagram that is included in all 3 circles. And that would be this little piece right here, right? That's part of all 3 circles, and that's the only little segment that is part of all 3 circles, all 3 sports. So I got to put 15 right in there. 15, watch all the sports. Okay, what do we got next? 20 said they watch basketball and hockey. So remember from our example above, the and statement, the intersection, I'm going to draw it for you. Remember, and that little upside down U looking thing? Remember, that's the part that's included in both basketball and hockey. So where is basketball and hockey? That would be, I'm going to outline it in red. Unfortunately, I don't have a highlighter that's working right now. So that's basketball and hockey, right? And I have to have 20 people in there. Well, I've already got 15, so that means I got to put 5 right here because basketball and hockey has to add up to 20. Okay, hope that makes sense. You may have to erase your answers and go back and do this one again just to make sure that it sticks with you because I know this is a new thing for you. Okay, let's see what we got next. 23 said they watch only, this only should be right here. They watch only basketball and football. Only basketball and football. Okay, I'm going to draw around the basketball and football in green. Basketball and football. That's right there, right? The green, the part I drew around in green, that's basketball and football. 23 said they watch only basketball and football. I had to pause because I couldn't figure out what was going wrong here. What I have circled here in green or highlighted, that's not basketball and football because that includes hockey. You see this little piece right here that I drew the green around, that includes hockey too. So it's really only, let me go around it. Let me see if I can get my highlighter to work. No. So I'm going to go around it in black. This piece that I'm highlighting in black, that's basketball and football only. So I got to put all 23 of those people right there. Okay? Sorry for the confusion, but that little segment, the one I outlined in black, that is basketball and football only because remember this little piece right here, this little piece includes hockey, and I can't include hockey there. Okay, now I'm back on the right track. All right, let's see what's next. 25 said they watch football and hockey. Football and hockey. I'll just use black again. Okay, here goes my black color. You'll be better off if you'll use your color pencils and highlight these in because then you can use a lot of different colors. Okay, what am I looking for? Football and hockey. So here goes. I'm going to outline it. No, let me outline it in blue. I haven't used that yet. So football and hockey. Here's football and hockey. I'm outlining it in blue. Football and hockey right there. And remember this one right here, it doesn't say that we have to exclude basketball. So that's why we put that whole segment there. And I got 25 in there. I've already got 15. That means I got to put 10 right there. Okay, how about the next one? 35 said they watch basketball, but not hockey. Basketball, but not hockey. Okay, here's what I'm going to do. At the risk of confusing you a little bit more, watch this. I'm going basketball, but not hockey. Okay, so I'm going to cross out the not hockey part of basketball. Basketball, but not hockey. Because that 15 and that 5, that includes hockey. So that 15 and 5 have to get crossed out to not be part of the part of the basketball. So now I need 35. Well, I've already got this 23 right here. I got to have 35 altogether. So that means I'm going to put 12 in there. So what does that tell me? That I got 12 people who do what? Watch only basketball. That's right. Okay, next I got 75 people who watch football, 75 altogether. So what I got to do now is just make sure that all the numbers inside my football circle add up to 75. So I got to do 10 plus 15 plus 23, subtract that from 75, and that leaves me with 27. So I got 27 people who watch only football, 75 who watch football with other sports. And finally, 44 say they watch football or hockey, but not basketball. Okay, or remember, is that little figure right there? And remember what that is? That's the union, or is union. Remember the and is intersection. So 44 watch football or hockey. So that means I have to take into account everything that's in the football or the hockey circle, but not basketball. So when I take all those numbers then, that's going to give me a 7 right there. Okay, and I promise you, we'll do many more Venn diagrams if you find this one confusing. As a matter of fact, we'll begin the class tomorrow doing 2 more of this type. And so then finally, the question is, how many sports fans did I talk to all together? So what I got to do now, of course, is add up all those numbers, and including the 8. You got to be sure to include the 8 who didn't watch any of them. And when I do that, I get 107. Okay, so I think it would be a really, really good idea if you would erase those numbers that we put in there. Maybe tomorrow try to do this thing again by yourself. These do take some practice. They can be confusing, and we'll see you next time.